Okay, so this section is section 5.1 is called basic trig identities. That paper that you have is a paper that you're going to have to keep until the end of chapter 5, which is around, I would say, beginning of May. And then you're going to have to keep it because this paper you need it for the final exam. We're going to add the even and the odd identities also, and you need to make sure you have that paper with you at all times for quizzes, exams, final exams, okay? And obviously for homeworks. So what we need to do is fill it out. The first identities are the reciprocal identities. You remember these ones, right? Cosecant is the same thing as what?
Sine. The reciprocal of sine.
The reciprocal of sine. So that means that is 1 over sine of theta. So we're going to have to learn all these identities. Secant of theta, what is that? That is the reciprocal of 1 over cosine. That's right. So it's 1 over cosine of theta. Okay, and then we have the third one, cotangent. Cotangent is the reciprocal of what?
1 over tangent.
1 over tangent. And then sine, what is sine? Well, sine could be the reciprocal of cosecant. And then cosine is the reciprocal of secant. And here I was telling you yesterday for the exam that I always think about the first letter being the opposite. So if it starts with a C, then it's S. If it starts with the S, then it's C. S, C, C, S. So it always starts with the opposite letter, okay? And the last one, tangent. That's the reciprocal of cotangent. Okay, so those are the basic properties that we learned already in chapter 4. Now the next one is the quotient identities. And I've mentioned these identities when I cover tangent and cotangent, and I've mentioned when we're on the unit circle, I mentioned that tangent, it's a quotient identity for sine of theta over cosine of theta. And so cotangent, that would be the reciprocal of that, which is cosine theta over sine theta. Okay, so those are the basic identities that we already learned. Hopefully, right? Okay, now the Pythagorean identities. Okay, which is this one? Well, the Pythagorean, as you remember, is a squared plus b squared is equal to c squared, right? There's 3 properties that we have to, know. This is, the first one is cosine square of theta plus sine square of theta equals to 1. That's one of the identities. Now, that identity, we can rewrite it different ways. So that identity can be given to you in different ways. So you need to be able to identify that identity in different ways. Well, let's rewrite that identity. Like, for example, cosine square theta, and let me just make this a little bigger. Okay, so it's cosine square theta. That could be equals to, if I move the sine square theta to the right, I could have 1 minus sine square theta. But also I can have cosine square theta be equals to, if I put negative sine square theta first, then you're going to have plus 1. So those are the 2 different ways that you can rewrite cosine square theta. It's either way. You can rewrite it either way. You can put the 1 first and then minus sine square theta, or you can put the minus sine square theta when it comes to the right and then plus 1. Either way is the same thing, okay? Now, the second part of this is sine square theta. That can be rewritten as 1 minus cosine square theta. And also that can be rewritten as sine square theta equals first the negative cosine square theta, and then you can add the 1 after that. So that is cosine square theta plus sine square theta equals 1 in 4 other ways. So let's go ahead and do the same thing with the next identity, the next property. Let's rewrite it as tangent square theta. And that would be equals to two different ways. That could be secant square theta minus 1, or it could also be rewritten as tangent square theta equals -1 plus secant square theta. Okay. And those three identities, the next one is cotangent square theta. See, these three identities, somewhere, somehow, you have to find the time to memorize those three. Why? Well, because that way you can spot, that identity on the problem, and you can figure it out what to do with that faster. You're going to have this paper on the side, but it's always better to start memorizing those three identities, okay, to be more efficient. Okay, so now the next one. The next one is cotangent square theta that equals to cosecant square theta minus 1, and also cotangent square theta could be equals to -1 first, and then plus cosecant square theta. Okay? And now, if you use a 1, let me just rewrite both of them, because both of them could be 1, okay? Both of these can be rewritten. Let me see if I can delete. No, I cannot. But I learned something yesterday. Okay. Ah, okay. Okay. Undo. Okay, I'm just going to leave that there. I'm sorry, but I'll learn that later. Okay, so 1 equals, what is 1 equals to? 1 equals, it could be secant square theta minus tangent square theta. Or 1 could be negative tangent square theta plus secant square theta. And also 1 could be equals, if you look at that third identity, that could be equals to cosecant square theta minus cotangent square theta. And also 1 is equals to negative cotangent square theta, and then plus cosecant square theta. Okay, so these are 4 identities that you can, like 4 ways that you can rewrite these 2 identities as a value of 1. And why value of 1? Well, because in some of the identities, when you're proving these identities, you'll be able to say, well, all of this is equal to 1. And you can just scratch all of that, and you can just put a 1 instead. Okay? So now, we need to apply this property. So this chapter is basically proving identities. Okay? So let's move plus sign. Okay. The first one? Right? Okay. So then the first one, we have sine squared theta equals 1 minus cosine squared theta, right? So what we can do, we can use that identity. We can say, okay, sine is sine squared theta, it's equals to 1 minus cosine squared theta. So what I'm going to do on that second paper, this is where we're going to apply those identities. Now, we did learn to solve and to simplify these problems by what we did in chapter 4, by using the triangle and using the unit circle and all of that. But that is history already, okay? You're not going to be able to use that anymore. If you do that, you don't get credit for chapter 5. You get credit for chapter 4. So that problem is going to be marked wrong, and you will receive no credit. So please be aware of that. You need to, in chapter 5, you need to be able to prove identities and get values of trig functions by using the trig identities. Okay, so problem number 1. And number one, it says, find sine of theta if tangent of theta equals to -5/12. Well, I need to find sine of theta. If I look at my three identities, look at the three identities that you have. Which one has sine? Existing recording. Okay, just keep on going. Okay, so then what I'm going to do is I'm going to go ahead and substitute instead of sine of theta. I have tangent equals to -5. Okay, well, I have that one that has sine, but it doesn't have tangent. So if I look at the back, on that page, which one has sine and tangent? Is there one that has sine and tangent? The third one? Right? The third one has, that's right. So the third one has cosecant, and it has also cotangent, so it's a reciprocal of both of them. So what we're going to do, we're going to use the third one, which is cotangent. Let me just make this bigger. So this is cotangent. Let me just rewrite it. Cotangent squared theta plus 1 equals cosecant squared theta. Okay. So then cotangent squared theta is just a reciprocal of tangent. Okay, so what I'm going to do, I'm going to go and get the reciprocal of the value that is given to me, which is this one. So I get that value and I substitute it. So this is -12/5, and this is only tangent, right? When you get the reciprocal, it's cotangent. And then you square that amount. And this is cosecant squared theta. Now I need to simplify that. So here, -12 squared is 144. 5 squared, it's 25. And now what I'm going to do, I'm going to rewrite 1 in terms of 25s. And that would be 25/25. So what I'm doing, I'm converting that 1 into 25ths. Why is that? Because I'm going to have to add those two. So I want to have the same common denominator. So the denominator is 25. So that 25, I can convert this one as 25/25. So instead of writing +1, I'm going to write 25/25. So I'm already converting that so that I'm ready to simplify. Okay, so now I can add those two fractions. 144 plus 25 is 169/25. And this is cosecant of theta, square theta. And now I need to leave cosecant by itself. It has a square, so I can get the square root of both sides. And let me just write it first as cosecant of theta. I'm going to put it on the left. And square root of 169 is 13. Square root of 25 is 5. And now that is cosecant. But I want sine. So if that's cosecant, I can get the reciprocal of that, and that would be sine, right? So then here, sine of theta equals 5/13. Okay? So that is sine of theta. Now all I have to do is just make sure that the sign is correct. Okay? So as you recall, since I have a restriction here, cosine is positive and tangent is negative, I have to go back and I need to make sure that I have the right sign. So if I go back to...
Oh, so that's what we did.
Yeah, that's right. So we need to make sure that we have the right sign for sine, okay? So in which quadrant am I going to put sine so that cosine is positive? So which quadrants do I eliminate if cosine is positive? It's greater than 0. The first and the fourth, right? Okay, so then I'm going to scratch out the left side. Okay, now tangent is negative. In which of those two quadrants tangent is negative? It cannot be in the first quadrant because all of them are positive in the first quadrant, right? So it has to be in the fourth one. Okay, so now the question is, what is sine in that quadrant?
Negative.
It's negative. So then the answer, when I give the answer, is going to have to be, okay, sine of theta equals, and then I put my answer. So here I'm going to put sine theta equals -5 over 13. And that would be the answer. It's negative, yes. Okay. Now let me let you work in number 2, just to think about the property. Okay, so look at number 2. Check on which identity is the one that you have sine and cotangent. So then for number 2, we have to use a third identity because that has cotangent and it has the reciprocal of cosine, which is sine. So we need to start by doing that. So let me go ahead and just move to the right and work it on the left-hand side. Okay, so then let me copy that property. It's cotangent square theta plus 1. Now, since I want sine, what I'm going to do, I'm going to use that. Okay, it's already on the right-hand side, so never mind. Let me just leave it like that. Cotangent square theta plus 1 equals cosecant square theta. Now, I'm going to substitute. Cotangent is negative 4. So instead of cotangent, I'm going to substitute that for negative 4. Okay, and now negative 4 times negative 4 is positive 16. And 16 plus 1 is 17. And then you square both sides, square root, I'm sorry. So when you square root both sides, you're going to have, let me just put cosecant of theta on the left-hand side, and that is square root of 17. Okay, now, I need sine. I don't want cosecant. So sine is, if I rewrite it as sine of theta, that would be equals to 1 over square root of 17, which is the same thing as square root of 17 over 17 when you rationalize, right?
Yeah.
Why? Well, because you multiply top and bottom by square root of 17. And that gives you square root of 17, and square root of 17 square. That cancels out, and you end up with just 17. So it's the square root of 17 over 17, right? And now the question is it positive or negative? Well, let's check on the graph, yes. Okay, so let me go ahead and put cast. I want cosine to be negative. So which quadrants do I eliminate? The fourth one and the first one, isn't it? Because on those two, cosine is positive. And I want cosine negative. Okay, now the second restriction is that cotangent, which is tangent, it's negative. So which one do I eliminate? The third one, right? Okay, so I eliminate the third one. Now the question is, I have sine. What is sine in that remaining quadrant? It's positive, so my answer would be positive. So that's the answer. Sine of theta is square root of 17 over 17. So basically here, we're getting values of trig functions, but now using the identities. It's just another way of getting the same values that we got in chapter 4. Yes.
Do we have to put like 17, square root of 17 over 17, or we'll put
1 over square root of 17 would be fine. And if you have answer choices, and if that's not on the answer choices, it's because they rationalize. And more than likely, they rationalize. Yeah, okay? Okay, now go ahead and try number 3 by yourselves. So number 4 and number 5, it says use identity, basic identities to simplify the expression. So these problems, all you have to do is just simplify using identities, okay? So number 4, and problem number 4, cotangent. Okay, what is cotangent in another way?
Cotangent is 1 over tangent.
That is 1 over tangent, okay? 1 over tangent of theta times. What is secant of theta? And here we have to kind of like, plan ahead. Okay, 1 over cosine. Okay, 1 over cosine. And then this is just sine of theta. Now, so far I don't have anything here that I need to, that I can cancel out. So I got to do something with that cotangent, okay? That cotangent is not helping me. So it seems like I got to have everything in terms of sine and cosine. So look in the identities. Is there any other way that you can rewrite cotangent in terms of sine and cosine?
Yes.
Yes, well, what is cotangent in terms of sine and cosine?
Cosine over sine.
Cosine over sine. Okay, so now if I have this, now I can say sine of theta divided by sine of theta is just 1, right? Cosine of theta divided by cosine of theta, that's just 1. So all of this is just 1. Wow.
Why did you do that again?
Why? Well, because don't you remember that if you have, like, for example, 3 divided by 3, isn't that equal to 1?
Yes,
Okay. Negative 4 divided by negative 4, isn't that equal to 1?
yes.
Okay, so then sine divided by sine, that's also 1.
What about cosine divided by sine?
Well, you can just get rid of that because you did that.
Right?
No, you're cross multiplying.
You're multiplying across. So this is the same thing as having it. Let me just rewrite it so you can see that.
Okay.
This is the same thing as cosine theta sine theta, if you rewrite it, over sine theta cosine theta. And do you see that here? You can just cancel out those two and these two. And that is equal to 1. Right? So either way you want to do it, if you have on top and on the bottom the same identity, you can just let that be equal to 1. Okay? Just 1. So all of that is just 1. Okay. Wow. Number 5. Can we simplify that number 5 into something else? Okay. Well, look at the identities that are given to us. Cosecant, cotangent, and secant. What can we do here? Cosecant could be what?
Sine? No.
1 over
Cosine over sine?
sine of theta? Right? Okay, now times. What could cotangent be that has sine? Because it seems like the first one has sine, so then can we rewrite cotangent in terms of
Cosine over sine.
cosine over sine? Okay, so it's cosine of theta over sine of theta. Okay, all of this is divided by secant, and secant is the same thing as what? In terms of cosine and sine, because we're using cosine and sine all the way.
Is
So
1 over
1 over
cosine?
cosine. There you go.
Wait, is it?
Yes. 1 over cosine of theta, that's secant. Now, this right here is just a fraction divided by a fraction. Okay? So in algebra, in math, we learned that a fraction divided by a fraction is the same thing as multiplying by the bottom reciprocal fraction, right? Okay. Right.
It's a
Right.
fraction within a fraction. It's
Right.
substitute.
Where is the fraction? Well, let me go ahead and rewrite it over here. The fraction would be, if I multiply across like that, that would be cosine theta divided by sine square theta, right? Because it's sine times sine. And now that product, well, that fraction, when you multiply that, you can multiply that by the reciprocal of the bottom fraction, which is cosine theta over 1. Okay, so now, what is cosine times cosine?
Cosine squared.
Cosine square theta over sine square theta. And now, did you identify that cosine over sine? What is that equals to? Look at your identities formula chart. What's that? Is cotangent, right? So all of that, let me just rewrite it. At the end, you don't have to copy this down until the end. Therefore, cosecant theta times cotangent theta, I'm just rewriting the problem, divided by secant theta. All of that is just cotangent square theta. And that is the final answer. Okay.